Good morning, mathematicians. Today we'll be doing lesson 7.7, equivalent fractions. The objective for today is to guide the development and use of a rule for generating equivalent fractions. Let's get started with our warm-up. Today we're going to name all of the factor pairs for each given number. Remember that factor pairs are sets of numbers that multiply to equal a specific product. So let's look at 6 as a reminder. The factor pairs of 6 are any pairs of factors that multiply to equal 6. I know that 1 times 6 equals 6, so that's one set of factor pairs, and 2 times 3 equals 6. So there's another set of factor pairs. There aren't any more numbers that when I multiply them equal 6, so that is all for the number 6. Go ahead and list the factor pairs for the numbers 4 and 5. The factor pairs for 4 are 1 and 4 and 2 and 2. 5 is a prime number, so the only factor pair it has is 1 times 5. Erase your boards and let's get started on the next set. Find all the factor pairs for the numbers 12, 15, and 21. The factor pairs for 12 are 1 and 12, 2 and 6, and 3 and 4. The factor pairs for 15 are 1 and 15, and 3 and 5. And finally, the factor pairs for 21 are 1 and 21, and 3 and 7. Erase your boards and we'll get started on our last set. Write all the factor pairs for the numbers 50, 52, and 72. The factor pairs for 50 are 1 and 50, 2 and 25, and 5 and 10. The pairs for 52 are 1 and 52, 2 and 26, and 4 and 13. And finally, for 72, it's 1 and 72, 2 and 36, 3 and 24, 4 and 18, 6 and 12, and 8 and 9. Go ahead and erase your boards and put them to the side. Then you can open up your math journal to page 201. Today again we're going to be working on finding many names for fractions. I want you to take a couple minutes and complete this page on your own. The directions say color the squares and write the missing numbers. So for number 1, you're going to color 1/2 of each large square and then write the numerator on top for the amount of squares colored, or the amount of pieces colored. In number 2, you're going to color 1/4 of each large square. And then in number 3, you're going to color 3/4 of each large square. Go ahead and do that now. This is what your page should look like all colored in. Who can tell me for number 1 what the missing numerators are for the 2 boxes? Correct. The second fraction should be 2/4 and the third fraction should be 4/8. Now, who can help me with number 2, filling in the numerator for each of the fractions? Correct. The first box should be 1/4, the second should be 2/8, and the third should be 4/16. And finally, who can help me out with number 3? Yep, the first box should be 3/4, the next one should be 6/8, and then the last one should be 12/16. Notice that all 3 fractions that you wrote for each problem all name the same fractional part of the square. Those are called equivalent fractions. Maybe you also noticed that whenever the total number of equal parts is doubled, so here we went from 2 to 4, the number of colored parts is also doubled. But the fractional part represented by the colored parts doesn't change. It still covers the same amount of space. Today we're going to work on finding a rule to find equivalent fractions. Let's take a look at number 1. We started with the fraction 1/2. And then to get to that second fraction, we could multiply the numerator and denominator by 2 because we doubled the amount of squares. So when I multiply by 2, my numerator now becomes 1 times 2 equals 2, and my denominator becomes 2 times 2 equals 4, 2/4, which is exactly what we had right here. To get from the first fraction to the third fraction, now we multiplied by 4. So let's try that. We started with 1/2. And then to get that next fraction, we multiplied by 4, because now there's 4 times as many equal pieces. So 1 times 4 equals 4, 2 times 4 equals 8, which again is exactly what we had right here. So that's showing that those are both names for the same fraction. So those are equivalent fractions. We can do the same thing with problem number 2. We started with 1/4, and now instead of 4 equal parts, there are 8 equal parts. So that's twice as many equal parts, which means that we doubled our fraction or multiplied it by 2, which equals 2/8, same as right here. And to get to that last one, we started with 1/4, and this time there are 4 times as many equal parts, so we multiplied by 4 on the top and the bottom, and we get 4/16. Looking at number 3, we started with 3/4 each time. And to get from the first one to the second one, we doubled it. So we multiplied by 2 on the top and bottom. And so we have 6/8 for the second fraction. And this time now, we quadrupled it or multiplied by 4, which gives us 12/16, which is the same as what we have here. What we just looked at was something called the equivalent fractions rule. If the numerator and denominator of a fraction, say 1/2, is multiplied by the same non-zero number, you get a fraction that is equivalent to the original fraction. So in the past example, we multiplied everything by 2 over 2 and 4 over 4, but I could multiply this fraction by any number. So if I wanted to multiply 1/2 by 5 over 5, the fraction 5/10 we know is equivalent to 1/2. I could do the same thing with 1/2 times 3 over 3. 1 times 3 equals 3. 2 times 3 equals 6. Another fraction that is equivalent to 1/2. So this is an easy way of being able to come up with equivalent fractions. Now turn to page 342 in your math journal. Let's take a look at 1/3. And I would like you to use the equivalent fraction rule, so multiplying the numerator and denominator by the same number, to come up with 5 fractions that are equivalent to 1/3. Go ahead and do that now. You could have come up with lots of different names for 1/3, but some that you might have come up with are 2/6, 3/9, 4/12, 5/15, 6/18, 7/21. Today in our learning journey, we already completed mental math. We also completed Math Journal page 201. Your next task is to do Math Journal page 342 and 343. Find 2 more equivalent fractions for each fraction using the equivalent fractions rule. Then you'll be working on Math Journal page 201B, which is some adding and subtracting of mixed numbers. And finally we'll end with an exit slip that I will give out at the end of the day. If you're moving on to activity B, you can just go on today to blend space practice G. And if you're activity C, you'll be doing Math Masters 224 and then blend space practice G. Make it a great day.